All right, David Ken here with another question from topic 6.1. In this question, we're going to be qualitatively describing circular motion that results from gravitation. In this question, what we have is a satellite orbiting Earth at a constant speed. Here's the Earth, here's the satellite, and the arrow shows that the satellite is going around like this. On the diagram, add an arrow and label it F to show the direction of the gravitational force of the Earth on the satellite. Well, gravity always acts between the two objects in the line between the two. So the satellite is being drawn towards the center of the Earth. So there's the force due to gravity, labeled F. But it doesn't fall in towards the Earth, it falls around the Earth. So when we add an arrow and label it V to show the direction of the velocity of the satellite is actually this tangential velocity here. Now velocities are vectors, so they're always straight lines. It's not a curved line. Just at this instant, the satellite is traveling in this direction. If somehow, through magic, we were able to poof the Earth out of existence and it just disappeared, then the satellite would continue to travel along this line. So that's its tangential velocity at that moment. Now the relative lengths of the arrows are not important here because they're completely different units. So we can't really compare them. We can only compare their directions. Force is in newtons, velocity is in meters per second. So we just need to make sure that we get the directions right. Part B says, although the speed of the satellite is constant, it is accelerating. Explain why it's accelerating. Well, there's two ways you might think of explaining why it's accelerating. You might say it's accelerating because it's moving in a circle and therefore experiencing a centripetal acceleration. But if you read the question carefully, it gives you a hint as to how to answer it. It says, although the speed is constant, which means they want you to address the issue of how it can accelerate despite the speed being constant. So to get the marks here, what we actually have to say is the direction of the velocity is changing. And because the direction of the velocity, and because the direction of the velocity is changing, there is a changing velocity. It doesn't matter that the magnitude stays the same, it's still a changing velocity, and therefore an acceleration. Part C says, discuss whether or not the gravitational force does work on the satellite. And again, there's a couple of ways that we can think about this. Remember, work is the transfer of energy. Is the satellite receiving any energy? Well, what kinds of energy might it receive? It might receive kinetic energy, in which case it would travel faster. But it moves at a constant speed, so it can't be receiving any kinetic energy. It could be receiving gravitational potential energy, but to do that, it would need to be moving higher in the gravitational field, and it doesn't do that either. It stays the same distance from the Earth. So one thing we could say is that the satellite receives no kinetic energy, it receives no gravitational potential energy, therefore it could not possibly be having any work done on it. But if we want to make a more formal approach to this, we could say that the definition of work is F, the force on the object, S, the displacement of the object, cosine theta, the angle between the force and the displacement. When we look at this diagram, though, we see that the force is centripetal towards the center of the circle, and the displacement is along the path of the circle, which means that the angle between the two is 90 degrees. And so since work is Fs cosine theta, and theta is 90 degrees, that means that the work must be 0. because the cosine of 90 degrees is 0. And 0 times whatever force times whatever distance is 0, which means that no work can be done on the object. This is the same case as if you were to push a block straight into the ground. Even if the block happens to slide one direction or the other for one reason or another, you're not doing any work on it because you're pushing straight in. You're not pushing to either side. So you're not doing any work on the block. And similarly, the Earth is not doing any work on this satellite because the force is straight in and the displacement is straight over. And that 90-degree angle prevents any work from being done on the satellite.